With me in the studio today is Ms. Shahad Yaqoubi from the Sultan Qaboos University, who is amongst the winners of the 9th National Research Awards as organized by the Ministry of Higher Education, Research and Innovation, having won in the Environmental and Biological Resources sector in Young Researchers category. She has joined us today to discuss her innovative research paper, the contents therein, and what it means to her to have won such an esteemed award. Shahad, welcome to the show. How are you feeling?
Good morning, everyone. It is a nice feeling that I am winning this award.
It's so lovely to have you here, and huge congratulations on winning the award. What can you tell us about the research project and its objectives?
So first of all, as we know that in Oman, the seawater intrusion has become a phenomenon that harms the farming activities and urban water supply in Al Batana and Salalah coastal areas. One of the widespreading approaches to control the seawater intrusion problem is through enhancing the aquifer recharge to maintain the hydraulic gradient seaward direction. However, the successful implication of managed aquifer recharge, we can call it MAR, to coastal aquifers require a good understanding of the dynamics of intruding saline water and its response to different external stresses emerging under MAR practices. MAR is a means by which water of good quality is injected into the aquifer to enhance its storage for later recovery. Implementing MAR may both improve the quality of initially present groundwater and also can control seawater intrusion by creating hydraulic barriers. So the using of sand tank experiments at laboratory scale is an excellent tool that allow us for a better understanding and visualization of what is most likely happening in a real aquifer. For that, the main objective of our research is to study the seawater intrusion under MAR practices using sand tank experiments. So in this research, we studied the effect of depth of injection well and the location of injection well from seawater boundary, and also we studied the impact of injection volume on the dynamics of saline water interface and the aquifer.
How is the implementation process of your research project?
In this project, we use sand tank is a rectangular tank that was made of transparent plexiglass. The internal dimension of this sand tank are 100 centimeter length, 15 centimeter width, and 60 centimeter height. This tank is equipped with two water compartments at both left and right side. The left side compartments contain fresh water, and this represents the upstream freshwater boundary, while the right side compartments contain saline water, and this represents the downstream saline water boundary. The fresh water and saline water supplied into the tank from two water tanks by using pumps. In this experiment, the hydraulic head in both compartments is controlled by using control valves. And also in this tank, there is the vertical distance at which these valves were located allows the selection of various heads of fresh water and various heads also of saline water. In this experiment, the flow rate of both fresh water and saline water into the sand tank was measured and controlled using liquid flow controller. This controller also can measure the temperature of inflowing water and record the total volume of flowing into the tank during the experiment. And intruded distance were measured by using a rulers attached along both the horizontal and vertical axis of this sand tank. Also, the tank was equipped with 3 injection wells for MAR practices, and also there is a 3 piezometers to monitor the water table level inside the tank by using water level sensors. Then the MAR was practiced through the injection well using pump and the liquid flow controller. And the parameters varied in this experiment included the depth of the injection, injected volume, and the location of injection well from seawater boundary. Also, the dynamic of saline water interface is measured during the experiment. And also, the water table mount was recorded by using the water level sensors, and we collected water samples from the tank to also monitor the salinity concentration of water. The volume of the marked cleaned zone for all runs were calculated by measuring the decreasing area of saline water. This will allow to know how much of injected fresh water is needed to clean a certain volume of intruded zone of the porous medium.
That's fascinating. Can you take us through the important findings in your research?
So the important findings of this research, first, the results of the sand tank experiment showed that the injected water away from saline water interface was less effective to mitigate the seawater intrusion by 32% to 61.4% compared to when we injected near to the saline water interface. And this is also depending on the injected volume of water. Also, injection of water inside transition zone caused to delay the reintrusion of saline water because the injection water built a hydraulical barrier against the saline water intrusion. Also, when we inject close to the coastal boundary, this caused to lose of injected water through the coastal boundary and caused less to push the saline water interface seaward direction. Also, the results of this experiment showed that injection at deeper depth was less effective to decrease the seawater intrusion compared with when we injected at shallow depth. For example, when we injected 1.06 liter of fresh water near the saline water interface at deeper depth, this salinized volume by 25.5% compared when we injected at the same volume but at the shallower depth. Also, during the injection, it is very important to monitor the height of water table mount to increase the effectiveness of MAR in decreasing seawater intrusion because a high water table mount may cause the rapid discharge of injected water happening through the discharge boundary, and for that, we will have less effect in decreasing seawater intrusion. In addition, the optimization of MAR practices in terms of the location of injection, depth of injection, and duration of injection, and also the rate and the volume of injection, along with keeping water balance for the aquifer, is essential to avoid the failure of MAR to reduce the seawater intrusion.
And during your research, did you
Yes.
face any challenges when conducting it?
Yes, there is the most challenges in this research that we needed to run our experiment for several hours. For example, when we start to run the experiment from 7 a.m., we need to continuously run the experiment and collect the results from 7 a.m. until 11 p.m., sometimes until 12 a.m. So this is the most challenges in this project that we need to run the experiment for several times.
And can you discuss the significance of your research project?
The effect of MAR in controlling seawater intrusion is site-specific, so it is depending on the hydrological features of the site and of the geological properties also of the site. So, since developing a good understanding of the dynamics of both the injected water and seawater intrusion in a small-scale experiment on the lab will be helpful for numerical and analytical modeling. So, for the successful implementation of MAR. Sand tank experiment at laboratory scale is an excellent tool that allows us for better understanding and also for visualization of seawater intrusion problem. This is difficult to observe in the field, but by using the experiment, we can have a good understanding about this problem. Also, the obtained experience and knowledge definitely will help in a better design of successful MAR system for mitigation of seawater intrusion, even in sand tanks with injection through point source with evolving blooms of fresh water. And also we can study the 3D effects are important in transient aquifer storage and recovery cycles. So the work presented in this study is to be advanced further to study the saline water dynamics, for example, in different hydrological conditions. And also this research will help us to understand how we can mitigate this problem here in Oman.
Congratulations once again for your achievement. Can you tell the listeners what winning the National Research Award means to you?
Actually, a sense of pride and happiness, especially since the project on this award, the National Award for Scientific Research, among the many participating researchers. Also, winning this award helped me to get an opportunity to participate in the annual researcher meeting. So in this meeting, we were able to convey the general idea about our research and also about our results of this study. And it is important to the decision makers here in Oman.
Thank you so much, Ms. Shahad, for joining me today.
Thank you so much for this invitation.
No,
Thank you.
Thank you so much for joining me today in the studio. It was truly lovely speaking with you. And listeners, there you have it. She's one of the winners of the National Research Awards, who has won the award for her research paper into preventing and combating saltwater intrusion into our water supplies. Thank you so much once again for coming